Hi, my name is Spencer. Again, I'm a fourth-year medical student here at Columbia. I'm going to now teach you about data types. In the last video, we talked about data structures, which are data frames, lists, and vectors. But now we're going to talk about data types in R. These are the actual individual values of data and how we categorize them. Depending on the data type, we can do different things. There are three major data types to be aware of for most purposes in R. There's numeric data, which could be real numbers, integers, or decimals. There's logical data, which are also called Boolean values, which are true or false. There's also character data, which some languages call string. I will often interchange between calling them characters or strings because string tends to be the most common word people use across languages. Numeric data is exactly what it sounds like. Any data value that is a number. It can be a decimal or an integer. It can be positive, or it can be negative, or it can be zero. You can initially define it based on other parameters. For data storage purposes, R actually subclassifies numeric values into three types: integers, single precision, and double precision. Most numbers in R are presented in double precision, which is called double in R. All of this detail is sort of unnecessary for basic statistical programming, but just know that different levels of precision take up different amounts of memory. So double memory takes up more memory than single memory, but it starts to really matter when you have data sets that are millions and millions of points. We will be working on the order of hundreds or thousands of data points, so it won't make much of a difference. So here, I show you some examples of numeric data. Here I define a decimal, here I define a whole number, and here you can actually define a numeric variable as combinations of other numeric variables. If I ever want to check the type of a data point, I can use the type of command. Here you'll see that it tells me all of the variables I just defined are double variables. This means they are numeric. If I want to specifically check if a variable is numeric, I can use the is.numeric function. If I run that on these three variables, you'll see it returns true because each one of these objects or variables were in fact numeric values. This brings us to our second data type, the logical or Boolean variable. This simply tells us if something is true or false. R also interprets this as either a 1, meaning true, or a 0, meaning false. You can see that all of the previous variables were in fact numeric. So we had gotten true returned by the isNumeric function. You'll often use logical data to help subset your data or to define new data variables. This may come in the form of if statements, which are covered in another video that you'll learn about soon. Here, I'm going to show you how you can test different hypotheses and return logical variables. For example, is 5 greater than 3? We know that this is in fact true, so if I run this command, R will tell me true. Is 5 less than 3? No, it's not. So this should return false. Is 5 equal to 3? Well, this should return false. But I wanted to specify this because when you do comparisons for any sort of logical command, you use a double equal sign. This is extraordinarily common in all sorts of programming languages because usually the single equal sign is used as an operator to assign values, just like we use this arrow operator in R. So when I run 5 = 3, we should get a false. Now, just like any variable, you can store this information into a variable object. So here, I'm going to define my logical as, using the assignment operator, the test of 5 is equals to 30 divided by 6. For those of you who are not math people, 30 divided by 6 is in fact 5. So 5 is equal to 5. So my logical will now return a true. I can actually flip the logical variable to make it the opposite using an exclamation point. This is really helpful when I want to just reverse whatever statement I have defined. So here, my logical had been true. When I put the exclamation point in front of it, it will now be stored into my variable flipped logical, and when I check the value of that, you can see it is false. Again, you can always check the type of any variable by using the type of command. And you can also use the specific is.logical command to see if your variable is in fact a logical variable. So when I run type of, it tells me it's a logical. When I test to see if it's logical, it says true. All of those things check out from my perspective. Now, the third important data type that you want to think about are characters, which, as I said before, are also called strings in other languages. These are really just pieces of text that you can manipulate. So for example, I've defined my character as this sentence. If I run it, you can see that my character refers to this sentence. You can do all sorts of manipulations of characters or strings, and I'm going to cover that in another video because there's a lot to do. But for now, you can check to see if things are character type by using the following command. Type of. You can also check by using is.character, just like you saw with all of the previous examples. You may encounter situations where you have the wrong data type specified, and R is telling you an error. In these situations, you may want to convert between data types. So let's take the following scenario, where I want to do the simple calculation 3 times 4. So here, I'm going to define my first number as a numeric variable 3, but I define my second number as actually a character or string 4. If I try to define a new object called product, which is just the first number times second number, and I run it, you'll see I get an error. It's telling me that there's a non-numeric argument that's being passed to this operator. This is not going to work. This is because multiplication can't be done on that second variable. When I check the types of these variables, you can see the first one was a double, which is a numeric number, and the second variable was a character, as we had already seen. Now, if I want to convert easily between types, I can use the following commands. As.numeric converts to a number, if possible. As.logical converts to a logical value, if possible. And as.character converts to a character value, if possible. So let's use as.numeric to convert a logical. So here, my number from logical will be defined as taking the value true and converting it to a number using this command. When I see the value of my number from logical, it should pop out as 1 because true is equal to 1 from the perspective of R. You'll also see that I have successfully converted from a true value, which is a logical type, into a numeric type. And as you can see, 1 is my number from logical, and it is a double, which is a numeric type. Here I show an example of as.numeric to convert a character containing numerical text. For example, this is the new object, my number from character, and I'm defining it as numeric as the first 5 digits of pi. When I pass this string or character into this function, it tries to interpret it as a number, it stores it into this variable, and I can confirm that I've successfully changed the type of this value to a numeric value. So now you're going to try. Define a character variable that contains the year you intend to graduate med school. Once you've defined that character variable, convert it to a new numeric variable using the as.numeric command. Once you've done that, create a new logical variable that compares that one to the year 2022.